Good morning to all of you. We continue with our discussion on electrostatics. So, today we will start a very important topic in electrostatics, that is electrostatic potential energy. You have all learnt about gravitational field, and when you have an object in the gravitational field, to move the object you need to exert an extra force. So, imagine we have the ground surface here and I need to move an object from a certain height to another height. So, there is a gravitational force which is trying to pull the object below, and I need to apply a force against the gravitational field to move the object up. And so, I have to do work to move the object from a certain height to a larger height, which means that a work which I am doing actually gets stored in the form of a potential energy of the object. So, the potential energy, I can define a potential energy, which means that the object has some energy here. I move the object from one height to another height, I am moving the object against the gravitational field and I am doing work on the object. And so, when the external force does work on the system, the energy of the system increases, and so the potential energy of the object increases here. So, this is an example in gravitational field which you must have studied earlier on. In fact, if I leave the object here, the object falls down on its own accord, the field pulls the object down and the potential energy of the object gets converted to kinetic energy. We have a similar situation in electrostatics, where we can define an electrostatic potential energy. So, suppose let me assume that there is an electric field pointing down, uniform electric field pointing downwards. Let me call this as the x axis, this is some axis which I call z axis. So, I have a uniform electric field pointing downwards. So, if I have a charge here, say let me take a charge q. So, the charge q will be acted upon by an electrostatic force. Depending on the sign of the charge, the electrostatic force is either downwards or upwards. So, to move the charge from this point to another point, I have to apply an external force, and in that process the external force does work on the system. So, let me assume that I have an object at this point. So, let me call this position as xi and this position as xf. I stands for initial, f stands for final. So, my electric field is pointing downwards. So, as you can see from here, electric field is some constant times I cap with a minus sign. The electric field is pointing in the minus x direction is pointing upwards. So, what is the force, electrostatic force on the charge? It is minus q E naught I cap. That is electrostatic force. To move the object, to move the charge from xi to xf, I need to apply an external force which is negative of this, which is minus f electric, which is equal to q E naught I cap. So, I have to apply a force in the upward direction here to move the charge. So, that is the force that I have to apply externally, and what is the distance I must move? The distance I must move is so let me call this L vector is xf minus xi into I cap. So, I start from xi and move to xf, and I am moving like this from here to here. So, the length which I am moving, the distance by which I am moving is xf minus xi into I cap. So, the work done by the external force on the charge is equal to F external dot L, which is equal to q E naught into xf minus xi. So, if I call this height h, this is equal to q E naught h. So, this is the work done by the external force to move the charge from xi to xf, and this work gets stored in the form of potential energy of the charge. Please note that this is the work done by the external force on the charge. So, this equation is true for all kinds of charges. So, let me try to draw a figure here which sees what happens with various charges. So, I have the electric field pointing down. So, suppose my charge was positive and I move from here to here. So, the work done is equal to q E naught h, and q is positive. So, W is greater than 0. That means, I need to do work on this charge in taking it from this point to this point xi to xf. So, if I call the initial energy of the charge as ui, and final energy as uf, you see here in this case uf is greater than ui. The potential energy at this point is more than the potential energy at this point.